Hi, my name is Steinar Holøs. I'm the CEO and co-founder of MakeKit, and today I will show you how to build a shitty car or bot-bit. So this project here is for you who have the WonderKit system. If you don't already have that WonderKit system, please check it out in the link below. It's made for education and it's built around two base packages, and then you have add-on projects and learning tools surrounding it. This makes it perfect for you who wants to adapt your curriculum and want the option to add on different projects later on. This is also a lot more cost efficient than any other similar tools out there. So what is bot-bit? Well, you have already seen the pictures in the article, and you can base it out of either some cardboard box that you can find at home, recycle it and make a car, or you can choose the wooden frame. So these are the two ways of building it, and then I have some other tools which you get most of in the WonderKit system. You have the two cards, so I've cheated a little bit. These two are already assembled. Here you have the WonderKit circuit board you have here. Then you have rubber bands, battery, some nuts and bolts, and then you have servos. Here you have I've also attached the wheels. And then I have some strips. I will use this for the cardboard box to assemble that. And as tools, always have my handy cutting board. Then I have carpet knife. I have a small screwdriver. And then I have these pliers here, which can be handy in some instances. So these are basically the tools I need. Now the first car or option I will choose to build is this one, and for this one you can watch part 2 of the video, and I will show you how to assemble it with the frame. With the frame you also see some handy writing on it, where it states how you should connect the servos. So I just want to say that right now, because if you look at the servo, it has different colors on the wires, and it's quite important which way this goes into the card. So make sure you do that in the right way, and this here can help you with it. So now the first thing I want to do is maybe start with the code. But before I do that, I want to say a little bit about what's great about this project that I'm going to do here. So for schools, this can be a project that you can apply a bunch of different subjects. So you have problem solving, you have design and constructions, craftsmanship of course, and you can apply physics and math. Now the design work, it comes out of start being creative, you know. This is not only a box, you can apply this in many different ways. Try to be creative in what kind of car you want to build, and of course if you want to do more advanced things, you can always go into 3D or 2D and make your own design your own car. So now I want to start with the code. So I'm going to go into MakeKit, and then I'm going to makekit.no/docs. This is where I find the codes. Then I choose the WonderKit Explorer. I'm going to do that one more time. So here you have the WonderKit Explorer. Then I go down a little bit to reaction bit, and I find this one, the WonderKit Servo start code. So I'm downloading that, and then I can go into Microsoft Make code. If you don't have the links to all of this, You can check these out in the link below as well. So I'm going to choose import file. Then I'm just finding that file here. Open. Go ahead. So here it's initializing. And this is how it starts, and you see this here, Wonderbit it states. So now we can start building our code. Now I'm going to use, of course, 2 servos, so I'm going to put those in right away, I think. So I'm just... Now you don't have the servo 2 yet, so this is something I need to make. Servo 2. Put that right in there. So then I have the 2 servos. They are ready to go. Now the second thing I want to do is I want to do a start sequence, so I know that the microbit is actually doing the things I say it should do. So I'm just adding a heart there. Let that show for maybe 1 second before we do anything else. And before I do this, I want to have some variables. Now the key here is that I would like to be able to change how this car works later. This is why I'm going to add 2 different variables. I want to add one variable where the car drives forward. And then I want to add another variable that states that it's going to turn. Now, of course, you can choose later on what turning really means. If this means just turning, or if this actually means, like I'm going to do here, if you hit something or you add some kind of input from the microbit, then I want it to go backwards and then turn. This is because sometimes you hit a wall and then you really want to go backwards before you turn. So this is what I'm going to do, and to do that I'm adding 2 more variables. I'm adding one I call drive, okay, and then I'm adding another one which I state turn. All right, so I'm going to set these up as 0 to begin with. Just changing it into drive, so I have turn to 0, drive to 0, and when I've done this, then I can move on. Now the second thing I want to do is I want to make sure that when these 2 are 0, the car stands still. So then I'm going to put in a logic loop here, and I'm going to apply two different comparisons here. So first off, I'm going to state that turn is 0 and then also drive is 0. So if both these are 0, then so I'm just going to copy this one to make it easy for myself. And then I go in here and then change that to turn. So if both drive are 0 and turn is 0, then I want to set the servos. Servo 1 and servo 2. So you have servo 1, servo 2, and to make the car stand still, then you really want to have this at 45, because it's 1 to 90. 0 is going one way, 90 is going the complete opposite direction, 45 is the middle, so it should stand still. You might want to change this up a little bit. Okay, so I also want to make sure that I know when the car is standing still. So I'm going to show some kind of sign. So we can add any number of these. Let's say just a square. Now I know that it's standing still. And I can even add a pause here, but I don't think we need to. Okay, so the next thing I want to do, I want to make sure that I can start it, right? Because right now it's just standing still. Now, of course, you can apply maybe lighting or something like that. So try to be creative. I'm just going to use the button. So I'm going to apply button 1, button A, I mean. And then I'm going to have a variable here. So I'm going to add in this one. So what I want to do here right now, what I really want to do is I want to make sure that if I press A, I can turn it both on and off, right? So this is what I'm going to do. So I'm stating that if drive is 0, then I want the switch to turn, and if it's not, then turn back. Okay, so we try again and go back here. Let's see. Now go in, find drive. If drive is 0, then set drive to 1. And of course, if it's not, then we set drive to 0. So we go back and forth there. Okay, now I want to also have button B out here, and with button B I just want to turn everything off. So if nothing works, I want to just stop everything. Button B, okay. So now I'm just stopping everything with button B. Okay. So then we can move back here and we can apply the drive function. Now, this is something that you probably need to tune afterwards, because frankly, I don't know exactly which direction these are going to move in firsthand. So you might need to go back into the code and then change it. All right. So move this a little bit over here. So I add another condition. And then I add the drive loop. So I can just copy this one actually. But instead of setting it to 0, I'm setting it to 1. So what do I want to do if it's 1, then I want to set drive, no, sorry, I want to set servo 1 to, for instance, 10. Now I want to check this afterwards, because they might go in opposite direction than what I think. And then I set servo 2 to the opposite, because they will probably go in the opposite direction of each other. But I might need to change these two. And then I add an arrow just to show that this is what's happening right now. So now they are in drive. So I just add an arrow here. There we go. Now it should drive in one direction. It might go backwards, but then I just flip the code and fix it. Okay, so I applied this one. Then we need to apply the turn. Okay, so I add another condition here. And I actually, you can copy what you already done here. I'm going to use some of it again. So you have a turn, and then what you basically do is that you do the opposite. I'm going to do that. I want it to drive backwards. That's the first thing I want to do. So I'm changing, if you can see here, I'm changing it to the opposite of what's happening here. Now again, if it turns out that servo 1 is actually going in the other direction than I think, I just need to go in and change this back to something else. And then I'm adding another arrow here just to show that it's going, what's happening here is that it's going in the other direction. It's going backwards. And then I'm going to add a different scenario where it turns. So I'm adding this here. So I'm going to put servo 1 to 45, which makes the servo 1 stand still, and then I'm having the other servo go like 75. Okay, so this is what's happening right now. This is happening one time, and then when that is done, I want it also to show that it's actually turning. So I'm adding a different arrow here. Let's see. What we want to do here is actually this. So now it's turning at least one way. We'll see what's actually which way it is. Now you can have two turns. You can have like left and right turn if you want to. Apply this and you can actually choose different variables that make sure that it does this. Like the next thing I'm going to do is to apply a code where when it hits the wall, it's automatically going to go back and then turn. But you can also do this with lighting. So if you have less light, then you want it to do a different type of turn. This is something you can do. All right, so then you have this one, and I want to pause this a little bit because right now it's happening way too fast. So I'm going to add a pause between these. I'm going to set this for 1 second, and then maybe a little less for the turn. So we can say 750 milliseconds. That's how long it gets to turn. And when this is done, what I really want to do now is to change it. And this is actually the first thing also that I want to happen. But we can deal with this in a later function. Now, what I want to do after it's done this turn is to go back to driving. So it doesn't just stop here. So then I'm going to set turn to 0 and add another one and set drive to 1. And then it should go back to driving. So how do you turn now? Just says turn equals 0 equal 1, then turn, right? So I need to add a different function for it to actually know when to change. Now I'm going to use the new condition and add also a boolean, and then we have, then we add a comparison here. So I'm going to say that what I really want to happen here is when this car here hits the wall, then it should go straight into turning mode and go backwards and then turn. So then I have some input. I have acceleration. So we have this in X direction, doesn't really help us here, but Y direction, that can be quite useful. And then I put this up that I want it to be bigger than, let's start with 750 and see how that works. Now you might need to change this, and this you can find out. And then of course you want also another one that says this shouldn't happen in any other circumstance than when you're actually driving, right? So I now add another comparison and say that drive should be 1. So this is when it's measuring this. Then we can set turn to 1, but we also want to stop drive. So I'm adding the drive function here. Oh, I really want to have this on top. Drive to 0 and then turn to 1. And now the code should be finished. And we can see how it actually works. So this was the first part, and now I'm going to transfer the code. We can see how that actually turns out. So now I'm going to transfer the code into the microbit. So I plug the microbit. Make sure that you plug the microbit in and not the multi-bit or wonder-bit card. So I plug it in the right way. See, it lights up. So that's a good thing. And now it should be connected. It doesn't always work perfectly, but we will find out. This is because I've used this microbit before, so I've actually already connected it. Now it should, yes, it seems that it's downloaded correctly. Let's see if I have this symbol here. Yeah, right. Yeah, seems like it works. Okay. So the next thing is to build our little car. Okay, so I have the microbit ready, and now we can start assembling this. Now what I want to do is to have the wheels on the side here, and then I want the microbit on top here, and then we need to have the wires also, and I want the wires to go inside the box. The great thing about this kind of packaging is that you have this lines and so on, so I can actually use those as markers for where things are placed. Now I want the servos to be a little bit in front of the middle here, so I'm just going to use this line here on both sides, and then I use my handy knife and cut a hole for the servos. So I'm gonna cut a hole down here. Try to make sure that the lines are okay enough. This doesn't have to be perfect, just needs to be close enough. You can use the servo actually to just check if it's big enough. It seems that it should be there right now. So push it in like this, then we can test that out if it turns out to work. And I do the same thing for the opposite side. It can be helpful to just have one small line before you cut through the whole thing. So this is the way you do it with other materials as well, like gyps. It's the same thing with that. So do the same thing on the opposite side. Just push through, so you have now holes on both sides. These are holes for the servo, and then we can add a small line up here. This is because I really want to fasten this with strips. Now you can use rubber bands as well, but for this car here I will use strips. So I'm adding another line, just enough to have the strips go through. Okay, there we go. So doing it like this. Then I'm going to do the same thing on the bottom surface here. And then on the other side. You can use the knife to just push things through the box. And then again on the bottom of the car. All right, so there we go. 2 holes here and then 2 holes on each side. Okay, so I also want the microbit and the Wonderbit card to be on top here. And I want this to be right now in the middle, and I need a hole for the servo wires. So I'm going to add a little bit bigger line in the middle here, that we can push the servo wires through. Just do it like this, and then I want to use these screws on each side here to fasten the microbit. So I'm just gonna, if I have a pen here, yeah, I have a pen here, so I can mark where the center really are. Now I have 2 small marks. Use the knife just to cut a small edge. There we go, and now it should be able to push through. If it's not, I can have my handy little screwdriver and push through a small hole. Now it should work. Okay, so then we take each servo and then we try to push these through. And then we will try to connect them also. So I'm going to use these strips first, just to have these ready. Now I'm going to try to connect the strips so they doesn't fall apart immediately when I push through. Now I can try to just try to push everything through with the strips in. This will take a little bit more from my hand coordination, but that's okay. This should work, yeah. And then I add the strips just around the servo to keep it in play. Oh, this is why maybe I should have connected the strips before I started doing this. That's okay, we'll manage. So there we go. It should work. And maybe I can push the whole thing sideways. Yeah, there we go. Perfect. And I do the same thing for the opposite side. Doesn't have to be super tight, just tight it off so the wheel doesn't fall off. So now wheels are attached to the granola box. And now I will pull the wires through this hole in the middle. Now we want to have, don't want to mix these wires here. We want to have a little bit of control of which wire is which. There we go. Just pull these out to each side. Okay, now we can add them to the multi-bit card. And then, as I said, make sure that you follow orange, red, brown, and you push the connectors in the right way. Now a key here is that this looks like a face, the microbit, and brown is the ground. It's not literally the ground, but in this metaphor we use it as the ground. And push the wires in. There we go, they are connected here. And then we can attach the microbit and multi-bit card to the box. Now because this has an opening, I can use that as it makes it a little bit easier for me. But you don't have to have an opening actually. We have done this on different boxes without that opening in the front, and you can push things through in different ways. So now everything should be working. The only thing missing right now is the battery. Now this is why I have this is what we can do. We can either have it in front here using strips, or we can just push it down in the box, and I think I will do the latter. So I will just make a small opening in front here. And then we can have the battery inside the box. There we go, and now I can try to connect everything and see if it works. Okay. Seems like something is working at least, but we might need to adjust it just a little bit. Okay, let's press A and see if that works. Yeah, it's working, it's working. I don't know if it's going to stop, but this is what you need to do later. You need to go into the code and see if it's going to turn back. Maybe 750 is the wrong response, but then we can go in and fix that. But it works. And it stops. So there we go. Here you have the shitty car, or bot bit, if you will. Love to see you in the next video. Love to see you there. Then I will build it using this one. It's a little bit similar, but then we don't need the strips, and you use this instead. Here you can actually also attach a pen, so you can make your own artwork using code. So that's a cool thing. Okay, see you in the next video. Thank you for watching.